Hi, this is Silvia and welcome back to my videos. In today's OpenSees Cafe meeting, we got some interesting discussion and review at different OpenSees material wrappers. And so I wanted to share this with everybody because there's some really good and interesting stuff we discussed. If you want to join the OpenSees Cafe, we meet every Friday at 8 a.m. Pacific time and discuss whatever topic comes up within the group. There's a link in the description so that you can register.
MinMax material. Right?
Yeah.
But it's just freaky how long some of these little bugs have languished in OpenSees
And propagated.
and propagated. Yeah.
I just fixed a problem in my own material, so
Okay.
it's easy to do.
We need to get rid of this.
What does that do?
OPS export.
So how do you go to the?
Let me just see where where's the end if.
Can you open up the documentation for it though first? I'll find it and I'll give you the link.
OpenSees MinMax material wiki. Right?
Yeah, you got to put wiki.
Yeah. Okay.
So you have a new tag, the material that you're wrapping it on.
That's the one you're wrapping. This is the new. Oh yeah, that was, you had a comma in your statement, right? A new tag, the material you're wrapping on. Right. Yeah. Okay, and then the min strain and max strain.
And so this is the negative and the positive.
Yeah.
Limits. Can it be? Yeah, min strain can't be positive.
Right. Yeah.
Okay.
Well, I mean, it could, but
but then it would have to get there.
Then it would just fail right away.
Yeah.
unless you just had an initial strain or something. But yeah.
Yeah. Okay.
Yeah. So there's the there's the defaults. Which way we should probably use better logic than just using positive and negative big numbers, right, for the min and max. But
no,
I mean, what if you're strain is unitless, right? So I guess it doesn't matter. Okay. All right, so that's the OPS command, right?
Right, so that reads it in.
Yeah.
Oh, so here's a good question. So here it's grabbing, how does it check if the material exists? So where does it deal with the material? So the other material, it gets the uniaxial material, right? Stop, 67.
Yeah. So this is just for the creating the object, right? So it just gets a pointer. This just gets, this is the tag that you input, and then it returns a pointer.
So if you want to get information about the material, you could now this would be the first step. How would you then get information about?
I would probably do it not here in the OPS command, but do it in the constructor.
Right. Okay.
Yeah. So let's go down here. Okay. Yeah. So here you could check. Was it material dot get class type, or it's here? Let's look at Uniaxial Material. There's way too many. Oh wait, not that one. Maybe it's defined further up, but let me just go to let's go back to MinMax, but look in the header file. But I think it's usually defined in the header file because it's just an inline function. Yeah, this get class type. Return MinMax. It just returns a string. It's kind of an unsafe function, right? Because I mean, some bad actor could just change this name to whatever, or change this string to whatever. But you could call the material get class type and then string compare against elastic material. Right, so if you look in the elastic material, dot H. Right, it has that. So
That's pretty
that'd be one way to check. Yeah.
Yeah. And
But I could just go in and change this string, right? And then break your logic, Christian, right? So, probably a better way is get class tag, right?
But is that defined or just the type?
That's
you have get class type, but get.
Yeah, you could get the class tag, like the one that's used in the. But even that, it's not like a guarantee. Like somebody could just change the class tag and then break your logic, right? But
elastic
this
won't
thing,
change.
yeah. I mean, he could check against this number.
But that's a material tag.
Oh yeah, you could just say if material get class tag is equal to mat tag elastic material, right? Then you could. It would check against itself, right? This is defined in class tags.h.
Right, good. Well, but the material tag.
This one, right?
Right, but no, that mat tag elastic material.
Yeah.
That's the tag of a material that you've defined. Or what is this mat tag elastic?
That's
material?
the class tag.
Oh,
this big header file, right? It's all of these.
Tag. Okay, and those are unique. And so then you could pick here whether you want, you could even say 1, 2, 3, 5, 7.
Yeah. But but I mean, Christian, you could write in your code, you could write something like if material, I don't know if you can see this until I hit enter.
No, we see it. We see it.
Okay. Get class tag equals or mat tag elastic material, right?
That's a global variable?
Yeah.
Okay.
So then if somebody changed, came through and like changed this to like.
Yeah, it breaks again.
Well, no, this will still work.
Because
right,
you're not saying if it's equal to 1.
Because
If you
get
say
class tag, we'll just,
Yeah.
So that could be anything. 1. Yeah.
But you could do the
you
same
can make
thing.
this 900 and this would still evaluate to true. But if you check the class type and somebody changed that string, then.
Well, but you could do the same thing if it's equal to class type for the elastic material.
Yeah. But I'm just saying, like, somebody could change the string that's returned by get class type, right? Like if you said, and we're getting down in the weeds a little bit.
No, this is good because it's.
If you said if material get class type, I think is what it was, equals elastic material.
Well, no, I would say get class type dot material dot elastic of elastic. Can you ask?
What do you mean?
Can you ask for the class type of an elastic material, just like you asked for?
Yeah. That's if. Yeah, this material.
Well, no, but can I just say?
Oh, like globally or
elastic dot class type of, or get. So you would have to define an elastic
because you have to have an
material
object in order to. Yeah.
Okay. Well.
Yeah.
Okay. So this brings up an interesting question. Go to the H file for any one of these, not this H file, but even for the MinMax material, actually, this is good. Can you go to, I think that's what you have open in the other tab.
Oh, the other.
Oh, no, that's the
wiki.
No.
Yeah.
Right. You're not like me that you open up a million.
Yeah, I like to
tabs.
If I get more than like 8 tabs, I freak out. So, Okay.
I'm going to clear the screen.
Okay.
Okay, so here's a question for you then. This command right here, okay?
Yeah.
Can I make my own? Can I say get material input and return tag, comma, material tag, comma, min, comma, max.
Yeah.
So that if instead of doing a get response,
Yeah.
right, would that be, well, because I see them here, so that means that this would be specific to that material object.
Yeah, but you just want to get those back to
I just want to get the properties of that material. So I want my material to give that information out to maybe another I don't know. I don't have anything in mind right now, but instead of doing the get response, if I don't care what the current status is.
Yeah. You just want to pull
this
property. Yeah. I mean, there's like you could do print and like define a stream or something.
Yeah, but that gets
a little bit
if I
complicated.
Because then also for Christian.
Yeah. No, I just want to check Uniaxial Material. There might be something in the interface that does that. Let's see.
See if my circles.
No. Yeah, but what you would do is like there's like this thing here, like I don't know where that's used, but somebody snuck this in a while ago. But you could define another virtual, get input parameters, that just by default just like returns a null pointer or something.
Right.
So you don't have to define it for every material, right? You just give it a default implementation.
Oh, so I have to put it into this Uniaxial Material as well, not just in my own?
Yeah. I would put it in the base class. Define it as virtual. And then give it some default that just returns nothing, right? So then, yeah.
And so I can't just define a new function in my own material. It also has to be.
You can, but then then you can't. If you're dealing with Uniaxial Material pointers, you won't be able to call that function.
Okay, so
like you can only call it on. Yeah, this gets into like polymorphism and all that fun
like
stuff.
This doesn't have get class.
Yeah, I think that's probably higher up.
Oh, in the material class.
Or maybe even it's in one of the tagged object or movable object. Is that it? No. It's I mean, it's got to be somewhere, right?
Yeah.
Movable object.
Yeah, I don't even know these things.
There it is. All right. Okay, class type.
Okay.
Yeah.
Because it's more general than just materials, even.
Yeah, I mean, because any movable object. Yeah.
What's a movable object?
Anything that has send self, receive self. Right. This is where those are defined as pure virtual, pure virtual. Right. So. Yeah.
Well, so now.
And then also get class tag is here. Right.
Okay.
Both of those functions.
Oh, good. Yeah. You're right, because that belongs. So. Okay, so I can put in. So I would have to put in that extra function in the Uniaxial Material. But now, so. Well, I guess let's go through the MinMax, because that's going to show how because I'm thinking, let's say I want to get the strain, right? Christian wants to know what the strain is on that material somewhere else. That's pretty much what the MinMax is doing, right? You're going to go in and get the, how do you get how does it, because what if you use this many times what if you use this other material, you assign it to so many locations? How does other material know to check the min-max, or does the min-max know all the different instances, right? So let's go through, this is interesting because it's about communicating between different objects.
Well, it makes its own copy of
Okay.
the material that's being wrapped, right?
Oh, and
The
then
inner,
when you
it
assign
gets its
it,
own copy. So it's like a
Okay.
one-to-one thing.
Right.
Like it's, yeah.
but then the user, when you define your fiber section,
Mhm.
what material tag do you assign? Do you assign the min-max one?
The min-max, yeah.
You don't assign the one to which you've assigned the min-max then.
Right. Yeah.
Okay, so you never use the reference material. You always use the min-maxed one because that's like a wrapper on it.
Yeah.
Oh, okay.
Yeah, and I think somebody posted that several months ago on the group, the Facebook group. They were trying to use a wrapper of some sort, maybe min-max, but then in their element or fiber section or whatever, they were passing in the tag of the wrapped material.
Okay.
Or sorry, not that one.
Right.
Whatever the tag of
The
this
other
was.
material.
Yeah. Instead of this tag. And they're like, hey, it's not working, right? And there's no
Yeah.
errors or anything because you just have this extra material, but
Yeah.
you got to pass in the wrapper tag,
Okay.
not the wrap or wrappy or whatever
The other.
the other.
Interesting.
Yeah. Which it seems like common sense, but I guess it's not.
But
right?
it's not because
Yeah,
it's a
yeah, it's not.
wrapper and
You're like,
so,
oh yeah, put the wrapper on it. Now it should work. But no, you
Yeah.
got to pass the.
Yeah. It's
Yeah.
Excuse me. It's almost like it's mislabeled.
Yeah.
Yeah, because it's like, yeah. And how would you call it? I don't know. I would call it min-maxed material.
Yeah.
Right. That
Yeah.
it's the
Yeah. This should say other or
well, no,
wrapped
no, but
or
in calling the command, like you're saying, when you
like
define
here.
that object,
Yeah.
it's not min-max, is min-maxed material.
Yeah.
Right. Because it
Yeah. And we
means
should
it's
just put a
big.
note here that says, to use this material,
Yeah,
pass mat tag to your object, not other tag. Or,
that's a good idea. Yeah. Okay.
Yeah.
My material, however. Okay.
And I assume that in this kind of, like, for example, here you could use more materials, right?
Could
Not
use
just
what?
one. More materials, more tags of other materials.
For the min-max?
Yeah.
No, it's
No,
only
I mean,
one.
in a similar case, yeah.
Do what?
I said in a similar case, instead of using, because here is checking just one material.
Oh,
Yeah.
yeah. You could
But
just
you could
put
have two
more
or
input.
three and make some mathematical manipulation between them.
Yeah.
Yeah, but you would just have separate min-max materials for each.
Yeah.
No, but he's saying if he were to make a third material that has more input, you just increase the inputs here, and then yes, you create them, and then
Oh, for a new.
yeah,
Yeah.
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 kind of like a parallel material or something.
Yeah.
Yeah.
Yeah, because in my case, I have two, and I want to see which is the minimum between them, which goes the first one into nonlinear range. So that's why. Okay.
Yeah. Yeah. So
Yeah.
you could kind of do that, doing it through this process. See, it's got
This has factors. I knew there was some like undocumented, but these are just like multiplication factors on each material in the parallel sequence.
Okay. So. Oh, cool. So you can actually multiply.
Here, Christian, you could define like another set of min strains for each material, or max strains, right? If you wanted to do this in parallel, right? Like you could use this as a template or a guide, for doing multiple materials, right?
Yeah, and this is
just
really
getting
helpful.
The input. Yeah.
And what I learned and how things get read in the input, the first set of lines go through until it finds this flag of factors. And then it goes, and then so it forms a groups of this is the input and then this input, and then it will read, you know, this input and that input. So the first thing here is looking for where is this spot here. Okay.
Yeah.
And then you see it's looking for factors. Then it says, okay, everything before that is this. And so this here reads that. And then there's going to be a second section that reads this. Okay. Just so you know, that's what I've learned that it does.
Yeah, that's the best way to do it. Not all the materials do it that way, but that's how they should do it is, read, look for the optional stuff first, then reset the pointer back to whatever, right? I mean, that's what this is.
Exactly. It
This
goes
is
back
doing.
to the
Puts
beginning,
you back and then,
but it has counted how many of these inputs there are.
Yeah.
And so then it's going to read those in part 2 and then in part 3. Okay. Just as a parenthesis as to how this is done for reading different types of input. So that allows you to put in many, see how there's these dots. And so the user doesn't have to specify how many there are because it's looking for the end of that input and then it's going to read all that. Okay. So just as a parenthesis on that. So let's go back to the MinMax because I want to see what it does, how it gets strains and values. So you're right. So that's how it does it. And that's how it knows, because I was like, well, how does it know where that material is? But no, because the material is internally.
It just, makes its own copy. Right?
Makes its own copy. And therefore it says, okay, gets the information from the section itself, sends that information to the material copy, gets the stress strain, and then says, oh, wait, you've hit a certain strain. I'm going to return, instead of returning what you gave me, I'm going to return 0, right? That's what I assume it's doing. So, okay.
So here's the set trial strain, right? It's just saying if it's failed at the last converged state, right?
Which is just a
return
flag.
0,
Okay. All right.
And then, if, we exceed the strain limits, set the trial state to true, and then return 0 else, right? We haven't failed, and then just pass it on to the material. Right. So
it goes to material. It doesn't pass it on to, oh, it does. Okay. It passes it on to this section. Well,
to the wrapped material. Concrete 23 is wrapped by MinMax material.
Okay. Right? So it sends the current strain to that, and that returns.
Yeah, it just returns whatever. Yeah. So you're just forwarding the message.
Okay. Well, it's forwarding the message. It's sending the strain to the material. The material returns information, and you're just returning it directly. So this is where you would actually put in the flag and do your logic, right? So this would be the material 1, material 2. You check whatever the strains are there, and you return something else. If it's, you
can do it here. You can also do it in get stress. If we failed at the current state, just return 0. Otherwise, just return whatever the material stress is. Right?
Oh, okay. So this just returns the full object to the material.
Well, this is just saying, go to the material and call its set trial strain and return whatever the return value of that.
Whatever it returns. We don't know what it returns. But then, but now we've created this material, quote unquote, object. And so to it, we're doing get the stress.
Yeah, just chasing the pointer down.
Okay.
Yeah.
Because it could be complicated. Okay.
Right. Yeah, but the MinMax material doesn't care, right? It's just return whatever. Same with the get tangent, a little bit of voodoo going on here, but if we return 0 for the tangent, that can cause problems. This will cause problems too, but at least people won't complain about singular section stiffness or whatever, or their 0 length element, causing the equations to not solve.
But. And so you're doing 10 to the minus 8 because now times the material instead of returning 10 to the minus 8 fixed number, because that scales it. Maybe 10 to the
Yeah,
minus 8
scales it.
is,
And this is the
is too
initial
big.
tangent of the material. Yeah.
So that puts it, you know, 1/1000th or 1/10
10
1/1000000000th
millionth or 100
of
millionth.
a
Yeah.
reasonable number. So if you're metric, it's kind of, to me, it's a scale, right? I mean, it just puts it in the right order of magnitude.
Yeah. Instead of arbitrarily saying 1e minus 8,
It's relative.
which
Okay.
if depending on your units, right, could be it's unlikely,
Big.
but it could be a reasonable number, right?
Oh yeah.
Yeah.
If you're doing things in metric.
Metric
In
or
meters. I mean, if you're using meters as your base
meters
unit.
or kilometers or something, right?
Yeah.
Yeah. So
Okay. Oh, that's interesting. Okay. And so you have to put in, so yeah, so this would be the material for you to play with, Christian, and see. And so it would be, like you're saying, different springs are different materials, and then you combine so you've got the strain, which is good, because if they're in parallel, you know, here's the strain, get the stresses back, add them up, or figure out what you need to do to return it. Because, so if you go back to the parallel material, can we look at the
Mhm.
parallel material? So does that literally add the two stresses,
Mhm.
all the stresses,
Yeah.
by factors, whatever factors you assign to those two?
Yeah. Yeah. It's just springs and parallel. Right.
Yeah. And so this is the other one you might want to look at, is these two, or maybe just this one. I don't know.
But yeah, here's set trial strain, right?
Yeah.
It just gets the strain and then just drives it down to all the
Yeah. This
the
one sends it
materials,
to all
right?
of them. Okay.
Yeah.
And
This is
for
like a fiber section, but you know, there's no curvature, right? It's just everything is
yeah.
axial deformation, right?
Let's talk about the fiber section next time. I love to learn about it.
Yeah.
No, this is really good.
Yeah. I mean, this
Useful.
is basically the fiber section is just a parallel material, but with a weighting function with 1 and negative y, but and z, right? But,
Okay, next week, Christian, remind us to have Mike go through that next week. Oh, I'm excited. Okay.
Yeah. So it's
Okay.
saying, you know, if there's factors, then just
Or
if there's no factors, then just loop through the materials, add up the stress, right? If there are factors, just multiply by factors, right?
Oh, cool.
And then same with tangent, right? You just sum up the tangents. Right?
And so what does it do in series then? Go to the series material, please. We got 5 more minutes. This is perfect.
Series material is force-based element in 1D, right? It's just springs and
Of course, right?
springs and series. I mean, yeah, I mean that's
Yeah,
that's
but
all
so
it
what
is,
does it
right?
do? Oh yeah. So what is it going to do now then? It's going to get this, but I mean, how does it?
This is actually like force-based state determination, light. Let's say with the set trial strain, right? So it has a max iterations. It integrates flexibility and deformations, and then goes through all these, right?
Yeah, because this is more complicated, because it needs to iterate until everything is.
Yeah, until all the springs have the same stress, right? Yeah.
And then it returns. So what's the loop? What's it looping on?
Here?
Okay, so.
Yeah, just the maximum internal iterate, just like the force-based element.
And it does it, but it does it for a fix. So it doesn't, it's not trying to see, oh, if you've converged to exit. What are you checking on?
You want to make the strain, what is it? The strain in all the materials has to add up to the new strain.
Yeah.
Or whatever the trial strain is.
Okay. And so
That's what you're zeroing out.
Right. But there is no while, so it's going to do those iteration. It's not checking on anything though. It's just assuming that it's going to achieve it in that many iterations.
Well, here's
and if it doesn't, that it.
Yeah. So if it converges, right, then it'll kick it out. Yeah.
What if it doesn't converge?
I think it's just it becomes non-iterative. That's a good question. I haven't looked at this in a long time. Let me just check the inputs. Does it even let you give the? OPS series. Huh. It's not, yeah, it's not even letting you change the
Which is
max
fine,
it.
which is fine, but
Yeah, but
how,
if you
what
want to
if it,
know what happens when it's like you set max hitter to 1, if you want to know what happens, like you can.
yeah,
You'd have to
but what
compile some
does it do at the end of the loop?
down here.
Yeah,
Uh
updated stress is just DQ, which is the tangent.
the increment and stress. Yeah,
What?
because it's trying to find a change in stress that satisfies the compatibility of the springs and series. So it's like turning the global Newton iteration on its upside down, right? It's
Okay.
or inside out or whatever, right? Like,
Interesting. We can look
yeah,
at this next week. So Christian, this is the other material you also want to look at because it's got more complicated logic as well. That could be a help to what you need to do.
yeah,
if
but
you're
I
not
don't think
just
you'll
doing
need to
something
do
simple.
any.
No,
If you
but
need to do
it's
internal iteration or something, then
yeah.
yeah.
But yeah, I mean, you
Yeah.
might need to do that. So
Yeah.
so this is the other. So MinMax, parallel and series
And
materials
yeah, these three.
are
Yeah,
good.
thank
And this is really for anybody who's watching the recording. Hello, and made it this far. No, but this was really useful for me to see how much more you can actually do with materials and combining different spring behaviors within a single material.
Yeah.
So
But I mean,
And
if you
there's
if you
no
took
limit.
oh yeah,
I think
there's
there
no
is no
limit.
limit to what we can do.
I know, but it's good.
So,
It's just a little question.
sin cielo or
Sencillo?
without ceiling or
Oh, yeah.
como se dice?
Yeah, Cincinnati is
Uh,
almost the opposite without a sky. So
okay. But
Sencillo.
if you took a force based element like with some Lobato points, the points don't really matter, right? And then just applied an axial force, call it P. Just pure ax. Just put a force based element into tension, right? And then do a zero length element with the same number of springs as you have Gauss points up here.
Right, same concept.
Yeah. You should get the exact same results. I mean, they should be.
And if you do a material in series, or you do a single spring with those materials in series, you should also get the same results.
Yeah. This should be, like one material, with 5, or one series material with 5 or whatever, 4, 3.
Right. No, but I mean, that is the next level. So you could do it with zero length, and the iteration would be at the L. And that's the thing. So here's the interesting thing, because the iterations here are done within the element, right?
Yeah.
The iterations. Here, they're not. These iterations are done at the nodes.
Yeah. If you so I guess there's 3 models, right? There's this with the nodes. You just put them all in. Yeah. And then there's one with series
materials. And then this iteration.
It's all done here. Yeah.
Done. And that would be faster, I would think, if the iterations are done within the element than outside the element.
To do it inside the element?
Yeah, I mean, would this
should
be faster than having to communicate, with the big matrix and iterate? Because the big matrix doesn't know where the things are going, so it does everything at the same time. So this is cool.
But they should all be the same. I mean, you should get the same results for all 3 of these cases, like for the displacement of this node, right? Of this node.
Now you know what it's making me think of, what I could do with. Yeah, interesting.
Yeah.
Very cool. Great question, Christian.
Yeah.
Thank you. Great answers. Thank you.
Oh, I learned a lot. This was really cool for me, Mike. Thank you.
Yeah.
I
Cool.
think this was definitely a great session on not just how to implement a material, but just really understanding how to go beyond just doing that.
Yeah,
So
yeah. How
that's
the
cool.
wrappers kind of work and how they
Yeah.
just
Very cool.
yeah.
I
Like
have a suggestion also. I have a suggestion for how to read the OpenSees files. OpenSees files currently are very huge, and a lot of different types of data are different type of algorithms and functions are inside the files. But if you compress the file, it is very understandable. If you open your CPP file with, for example, Notepad++, and compress it using, for example, Alt+1 on Notepad++, you see the structure of the file. For example, in 10 lines, in 12,
yeah.
12
You can like
lines.
compress each method down to
Oops.
Yeah, that's
yeah.
really understanding and become very, very, very easy understanding of the file. And then
Yeah.
you can go inside each file.
Yeah.
Isn't that how it is with visual?
Can I?
Closing
Yeah,
all
Visual
the-
Studio, yeah.
Yeah,
Yeah.
I'm not sure with Visual Studio
Go ahead
Code.
and I'll.
Okay, I can show it. Yeah,
Yeah.
yeah.
Yeah,
Here.
it's good to get a preview of what they look like, and then
For example, do you have my screen?
Yeah.
Yeah, for example, this series material, or I just take a look to power material when you were speaking. This is very complicated at the start, but I click Alt+1. Okay, now I can see there is a function that defines the power material, and here I have a set string. Maybe here set string is I can see here there is no very complicated activity. This is not the main file, and maybe here we can find the main code. No, that's not here, but get a string, set a string, get stresses. We can understand what is happening here, and then we can go inside each other and get focus on that part of the code. It makes understanding of the behavior. Most of these functions, I can see that these are maybe here is this is send file. It is obvious that what does this function or method is doing, but it makes very sense, understandable for me. Makes sense for me in this way. Yeah.
It's funny. I was thinking of that yesterday. I was like, how can I do this automatically? And
that would be great if Professor Sky in next sessions, if you want to explain a file, that would be great. If he first tell us what does these methods do and where should we go for the main function of the CP file, that would be great.
Yeah, or maybe just because these all have kind of the same content. So yeah. Okay, cool.
Yeah.
Thank you.
Well,
Good.
Thank you guys.
Yeah.
Have a
Great
great
session,
weekend.
thank you.
Yeah, that was great. Thanks,
Have a great
Mike.
week.
Yeah.
All right.
Sure. Yeah. Okay.
Bye, everyone.
Bye.
Bye-bye.
Bye.
Bye.